right, class, let's continue taking derivatives. Here it is. Well, this one looks pretty bad, but I have a good idea. Because we have a radical and even a fraction, definitely I'm going to want to rewrite this function first before even attempt to take its derivative. So, see how we have a cube root here on the bottom? Yes? Okay, now what does a cube root mean? It means a 1/3 exponent. Yes? The thing is, I'm trying to do two things at the time. So instead of having 1 over the cube root of this, how else could I make this radical pop in the numerator so I don't even have a fraction anymore? Well, it means the exponent was negative, right? That's why they made it go down on the bottom in the first place. Good. So now it's perfect. I don't have a fraction. I don't have a radical anymore. It's just the composition of two functions, some inside function at an outside power. That's it. So what is the derivative of this function with respect to x? Well, again, I'm going to take care of that outside exponent first. So it's a -1/3. Leave the inside alone. So x squared plus 3x minus 7 to the power of, what is 1 less than -1/3? Again, when you minus 1 is the same thing as minusing 3/3. So that gets you a -4/3. Okay. Times, we're not done. We just got rid of the 1/3 exponent, or took care of that. But that wasn't all. It wasn't just an x to the -1/3. It was a whole bunch of stuff about x. So now that I'm done with the outside exponent, I need to move in and take the derivative of the inside. So what's the derivative of the inside? That's easy. That's a 2x plus 3. Okay. Now, I purposely did something wrong, and I'd like you to figure out what it is. So, hopefully your answer was that I didn't put parentheses around this. And if I wouldn't have put the parentheses around it, what does the order of operations say? That you're only multiplying this expression to 2x, and then the whole answer gets added to 3. But no, you're multiplying it to the whole 2x plus 3. So get used to putting parentheses. Without it is wrong. Okay. So what else do I have? I have my negative exponent, yes, that I'm going to have to take care of. So I have a -1/3. This guy's going to go on the bottom. So x squared plus 3x minus 7 to the power of 4/3, positive. And then the 2x plus 3 is a 2x plus 3 over 1. So this one gets to stay in the numerator, right? It's an over 1. Yes, so it's a numerator problem. That's it. All done. All simplified. No negative exponents. Again, I'm not distributing this in. Why? Because exponents before multiplication. So that's that. Okay. Pretty exciting. Ooh, this one's bad. Why is it bad? It looks like I have a composition of two functions, and it also looks like I have a quotient. And I could bring this one up to the top with a -1 exponent and change into a product rule, but it would still be a product rule. It's not just divided by one tiny thing. So it still would be a product. So what do I mean by that? I mean that I could rewrite this as an x plus 4 to the 5th times the whole 2x to the 3rd minus 5x to the power of -1, right? This whole thing is to the power of 1. So I can bring it to the top, and it has a -1 power. Now, this itself is still quite a bit to work on. It's a product. I can't multiply it. I can't undo that product. So I'd still have to use the product rule. And I think even though the quotient rule is a lot of work, it's still fine. So we're going to use the quotient rule because of the quotient we have and can't undo. Why was it so easy to undo here? Because the numerator was just a 1, right? And the 1 times that, that's just that. So it's not another whole thing like here, right? Where I would still have a product rule to deal with. Okay, so the quotient rule, let's practice on that, says take the derivative of the top. What's the derivative of the top? Well, again, it's a 5. Leave the inside alone to the power of 4 times. Move on the inside and take the derivative of the inside, but that's just the 1. So that's just the derivative of the top times the bottom. Minus is the next step. Leave the top alone times the derivative of the bottom. What's the derivative of the bottom? Is a 6x squared minus 5. And again, what did I forget to do? I didn't put the parentheses. Again, if you leave it like that, this is the only thing that gets multiplied to the parentheses. The negative 5 is a different term, but that's not the case. You multiply to the whole derivative of the bottom times, or I'm sorry, over the denominator squared. Okay, and that's about it. There's not much to simplify. Fine, the only thing to simplify would be the 5 times 1, and fine, 5 times 1 is 5, so that would make it disappear. I don't want to copy the whole thing. It's a lot to copy for just 5 times 1. It goes away. So I would just erase this here and leave it as a 5, which, yeah, pencils are nice. All right, why can't I multiply and do anything? Again, to multiply this means to take this parentheses apart 5 times, this one 4 times, and then times some more. That's just way, way, way too much work, and we don't need it. We just want to practice on the rules, okay? All right, next one. Here is a product, okay? And we cannot avoid this product. Why? Because we can't multiply this x to the third to this radical. So, I mean, we could, if we could bring it back inside the square root if you promise to make it an x to the 6th power. So, if algebra skills are really good, yeah, you could do that. But I'm going to leave it because I also want to practice on the product rule. So I'll show you what I could have done. But the one thing still, what do I need to do? I need to rewrite my square root as a 1/2 exponent. Yes, so I could use the power rule. What I was trying to say really is that you can put this x cubed inside the square root, but you have to make it an x to the 6. And with that x to the 6 multiplied in there, right? Because again, remember, when you simplify radicals, what do you get to do? You take perfect powers out, so the square root of x to the 6, the 6 gets cut in half, right? And that makes the x to the 6 come out and the rest not. And then this is easy to multiply, and then you really don't have to deal with a product on top of a chain rule. So that's how you could easily avoid that. But as I said, I'd like to practice on the product rule as well. So I'm going to leave it. So what's the derivative of this? Now, it being a product, we have to take the derivative of the first factor times, leave the second one alone, okay, plus leave the first factor alone, times take the derivative of the second factor. Now, how do I take the derivative of this massive factor? The derivative of this massive factor is a chain rule, right? It's two functions chained together. So leave the inside alone at first. But then times, Move on and take the derivative of the inside. Put that in a parentheses. So the derivative of the inside, it's going to be a 20 x to the third plus 18x and minus 8. So I still have to simplify some things here. I don't mean distributing. Again, you can, by the way, because you would have to take care of the exponent first, right? The exponents before multiplication. But mainly what I need to do is take care of this negative exponent here. So there's that. And if you want, you can rewrite this back as a square root. But this is what I got to put together. So I have an fraction for sure. What's going to stay at the top of this fraction? The x cubed. And by the way, this thing here as well, the 20x to the third factor plus 18x and minus 8. So these factors are over 1. And then the 1/2, and again, that means the 2 stays on the bottom. And this, having a negative exponent, is going to go right next to it in the denominator. And then it gets to get an opposite positive 1/2 exponent. Okay? And that's about it. There's no, you could simplify some more, adding these fractions, coming up with a common denominator, rationalize the denominators. That's enough. Okay? So the one thing that you still need to fix is always the negative exponents, right? Of course, multiplying coefficients, like if you'd have a 5 times a 2, right, somewhere here, then you'd put a 10 at the front. That's easily done. Okay. So, here are a couple more. And then we'll go on to the last topic. Okay, so 2 more problems. This one gives you a function, but it's asking you for what? What does this symbol here mean? So please read, okay? It's not always the same thing I keep asking you, so please read the instructions. That's important. So I'm asking you for the what? Second derivative. Okay. Great. Well, to get to the second derivative, I have to start with the first one. Okay. So what's the first derivative? Well, it's a composition of 2 functions, yes? An inside and an outside. I'm going to start with the outside exponent. Take care of the outside function, right? So the derivative something to the 5th power is 5 times that something to the 4th power times. Move on and take the derivative of the inside, which is what? 2x plus 2, right? 2x plus 2. Okay. Great. Now what? Well, I'm going to take a second derivative. What would I have to use in order to find the second derivative? Definitely the product rule, right? And why can't I avoid the product rule? Because I can't multiply these parentheses out, right? This one's to the 4th power. So unless I plan to multiply this to itself 4 times, it's not going to work. So I'm going to look at this as my first factor and this my second factor. So the product rule says, take the derivative of the first factor. So I'll keep the 5, right? Constant product rule times. Same thing, it's a chain rule again. So bring down the 4. Leave the inside alone, yes. To the power of 3, but you're not done. Why? Because now you need to move in and take the derivative of the inside, right? So it's a chain rule again. So I'm still about to take the derivative of the first. So it being a chain rule, take the derivative of the outside times, move on and take the derivative of the inside. That's a 2x plus 2. Times, I'm not done, the second factor, which is also a 2x plus 2. So let me write this down one more time. What did I do? This is my first factor. This is my second factor. Right here, I just took the derivative of the first, as the chain rule, as the product rule says, times the second factor as it is. Yes, that's the product rule. What else Now plus, what do we do next? Leave the first one alone, so 5 times x squared plus 2x plus 3 to the 4th times the derivative of the second factor. What's the derivative of the second factor? That's just the 2. Okay? So the product rule says take the derivative of one at a time. So the derivative of the first times the second plus the first one as it is times the derivative of the second. Okay, and I'm going to simplify this a bit for you. Why? Because 5 times 4 is 20. X squared plus 2x plus 3 to the 3rd times, look at this, these factors are repeating, so can't I write it as one of them squared, right? Plus, this 5 times this 2 makes it a 10 times x squared plus 2x plus 3 to the power of 4. So here is your answer for the second derivative. Now take the third derivative. No, thank you. Again, it'd be 2 chain rules and a product rule, right? And that's a chain rule, so that's quite a lot. So they could get worse and worse and worse, these second, third, fourth derivatives, right? Unless you're just dealing with a tiny polynomial that kind of starts canceling out, right? So in other words, if it was just an x squared plus 2x plus 3, the first derivative is just the 2x plus 2. The next one is just the 2, and after that they're all zeros, right? So one more function to it makes things complicated, right? It turns into product rules that turn worse and worse and worse. Okay. Remember this problem from 1.3? As I said, it's the same question, and we'll be solving it the same way. Equation of tangent line, find the equation of a tangent line. What we could do is play with different types of functions. So there is one for you. Okay, so it's a little bit similar to what we had above, but not quite. Okay, so how do I find the equation of a line? The equation of a line looks like y equals to mx plus b. Remember that? That's the equation of a line. Great. To find the equation of a line, I need 2 things. I need a point, and I need the slope. Okay, great. And again, you could use the point slope formula if you remember it, either one of them. Whatever you're most familiar with, you will need to know one or the other or both. It's up to you how good you were in algebra. Okay, all right, so we need a point and we need the slope. Do we have a point? Definitely, we're telling you the x value, where you draw that tangent line, yes, to the graph. So the x value is 1. How do I find the y value to it? Well, I find it by plugging this 1 into the function. Yes, that's how you find a y. Plug the x into the function. So that's going to be a 1, and f of 1 is going to be 1 squared minus 3 is negative 2. Negative 2 plus 1 is negative 1, and negative 1 to the 5th power, that's a negative 1. All right, so plug that into the function. Okay, so we have the point. How do I find the slope? How do I find the slope of the tangent line? Remember, the slope of the tangent line is always equal to what? The derivative of that function, right? But the derivative itself is going to be a function, right? Specifically, I wanted the tangent line where? When x is 1. So specifically, I'm going to have to find the slope of that tangent line by finding the derivative at that point, which is 1. Okay, so that's it. So that means what? First of all, I have to find the derivative, then plug in 1. What's the derivative? Well, it's a chain rule, yes? So remember, first, take care of the outside exponent times, move in and take the derivative of the inside, which is a 2x minus 3. Great. That's the derivative. What else do I have to do? Plug in the 1 into this derivative. Specifically, I need the tangent line when x is 1. Okay. Too many parentheses. Okay, so let's see, what do we get? Again, it's a 1 minus 3 plus 1. That's a 2 minus 1 is negative 1. Negative 1 to the 4th power is a positive 1 times 5 is 5. So here, 5 times, that's a 1. 2 times 1 minus 3, that's a negative 1. So altogether, that's going to turn into a negative 5. Okay? All right. So there you go. I have the slope. I have a point. I have the slope. And then I can just use the point slope formula to find the equation. So y minus y1, right, is equal to m, which is negative 5, times x minus x1. So the x coordinate of the point I'm looking at is 1. So that's a y plus 1 is negative 5x plus 5. And then minus the 1 over. So y is equal to negative 5x plus 4. Right? Sorry. So there it is. However, if you don't know the point slope formula, I'm going to show you one more time the other way. If you just know what the equation of a line is, first of all, you use the y and the x from the point we are given. We use the m from the m we found. And this simple equation gets you the b. So negative 1 is negative 5 plus b. I'm going to add the 5 over, so that makes the b a 4. But then don't forget, I'm not asking you what's the y-intercept or what's b. I'm asking you to write the equation. So y equals 2. In place of m, you write negative 5x plus b, we found it to be 4. Okay, and there it is. All right, so we're going to finish. We're going to stop this video here. I have one more thing to tell you about derivatives of functions on the next video.